So if we continue on from where we were before, such that we could click and colour in our window, if we want to make the game of life, we need to check the object that we click with the objects next to it. So we can check how many objects are alive or dead next to it. And by doing this, we can use the same process to make other board games. So we can check values of this object here against objects next to it. So now I'll show you how to index all the objects next to any object given. So now we'll quickly write that program. So first, to do this, we'll turn this block into a list so it's now more manageable as an object, so it can store its index values. So now we need to print off the first item from the list, indexing 0 from block. So we're now going to draw the graphics window from the list. And now we need to access the list down here as well. So we'll quickly change this to access 0 and this one here as well. So now we are accessing the list. I think that's all we need. Change, F5, save and run and check. Yeah, it's still working. Okay, now to get this code to access the objects next to it, which is quite complicated. Now as we can see, we've got the number 0 here, the block as index 0. We need to index the numbers 1, 10 and 11, but exclude anything below 0. And as for 99, we need to exclude everything above 99. So we're not going out the index range. Also, as for the values of 10, we need to make sure we're not going out the top of the screen. And I'll show you how we're going to do this to get the values next to it. So let's have a look at 14. We can get 3, 4, 5, 13, skip 14, 15, 23, 24, 25. Now to do this is quite dirty, so we're going to use this. So we're going to use a module, and we'll call this module board game. We haven't created it yet, but we'll just call it board game because we know we're going to. And we're going to get indexing, a function from it, which we're just about to make from the board game. So we'll write a new file in a Python document, and we'll save this one as board game. And then we'll import it into our module. So we'll import board game, just getting ready. And down the bottom here, we'll call board game indexing. Over here, we'll just simply define indexing, our function, and inside of it, to make sure it's working first, we'll print we made it. F5 to save and run this one, saving it as board game. Remembering it's case sensitive. F5 to save and run. We've got 5 lives to get through first. Or did I put 10? There we go, we made it. Beautiful. Now, just so we don't have to do that every time, let's put lives to 0 so it automatically goes to indexing. And in here we can write our program to get the indexing. What we'll do, once we get the index value for every object, one at a time, we'll append it to the list so that when we create our game of life or our other board games, so we can check the objects inside those index values next to it. So first, because I've already made this before, I know the values we're going to need to pass to it. And these are simply 3 values, being the blocks, being the list of blocks, and the squares along the X. Sorry, 2 values. And then this window here, we've called that the X scale. So we want the blocks and the X scale. I've called it squares X here because I think it's probably a bit more appropriate. Let's name it appropriately. Because we are going to be using this for other modules. And they may not be blocks, etc. So now first we need to make a check. And this is going to be our temporary storage of our index values. So it's another list. And now we need a number for our number of objects, which we can calculate here again, simply being the amount of squares along the X squared. Now we need to iterate for the range of the length of the blocks. So we get the index one at a time. So by doing this, for each object, we can start getting index values. Okay, now this is where it starts getting a bit complicated. Since we need to increase in the step according to the amount of squares there are along the axis, so if I ran this quickly, I'll hashtag this out so we're not running this. F5, save and run. So let's look at number 14. We want to get number 4 and number 24 at the same time, as well as +1 and -1 from those values. So the scale along its axis is how much less we want to iterate those 3 times. -1, then itself, then +1. So we can get to the left of the object, along its own axis, then to the right of it. Now this might be a bit complicated. Let's make step equal to index, just follow along, take the amount of squares along the x -1, and for number in range from 0 to 3, so we want 3. This could be a while loop instead. I'm just showing you can use a for loop or while loop. Now let's go count equals 0, so now we use a while loop, and we'll go while count less than 3. We need a temporary number to store a temporary number. So now what we're doing, we're getting every block one at a time, and we're getting a step equal to the block we have got, take the squares along the axis. So if we're getting number 4, we are taking off 10 and minusing 1 and starting here. We're doing it 3 times, so we're going 1, 2, 3, and then we're adding the whole scale to it and going across here and starting again and doing 1, 2, 3. Then adding the whole scale and starting again and going 1, 2, 3, adding these values each time. We want to exclude the index itself, so we're not checking itself. So now to run the rest of this, we just simply go if the current, being the current value, is not equal to the index, being itself, and current is greater than or equal to 0, and current is less than 100. We're excluding values outside the index range by using this range here. And now simply we go check dot append current. So we're appending the current value. Remember to count up the increment of this while loop. So count plus equals to 1. Now this step here, this is where we add a value of the squares to the step each time, then reset it. Because it is being reset each time using its index inside the for loop. Here, all we need to do is add the squares to itself. So this is where we increment along its axis here. And now we simply need to reset the checklist so we're not growing it every time after we've appended it. Now remember to append a checklist to the objects in the blocks one at a time, so that every block now has its own items to check next to it inside its objects. So now we can print off this list of the checklist for each item. So for number in range from 0 to length blocks, print index equals index the blocks using the num, and we want to access the second item in the list. So we want to access the index values we have appended for each value in the list of blocks. F5 to save and run. Whoops, I'm sorry, I'm used to calling that index. Let's call it num because it's number in this case. And here we go. We got our list, excluding values above 100 or in 99, excluding values below 0. So let's look at the index of 14 because we've been looking at it so far. We have excluded 14 itself, as we can see. So for 14, let's go 10, 11, 12, 13, 14. We have 3, 4, 5. Then we have 13, miss 14, 15. Then we have 23, 24, 25. And this is all stored in a list inside of it. So we don't have to check every object which is next to it, because we can check simply which objects are next to it on this grid, but to check every object and which objects are next to it each time would take too long. So by storing index values, we simply know which ones we need to check. But as you see, we're not done yet, because if we got the index value of 9, the index value of 9 will also access 10 and 20, I think, if we have a look. 9, yep, has 10 and 20 inside of it. So for 9, we need to remove 10 and 20, and we also need to remove 0. I've got a neat little trick way to do this. So if the index plus 1 modulo the scale is equal to 0, we'll remove all the values inside of it which modulo the scale equals 0. And if modulo the scale is equal to 0, we'll do the same thing. But we also need to do same for the values here on the other side. Follow me while we do this, I'll just do it here. And because it is dirty, I'll write it in another function. So now we're simply have this here, the cleaning function, before we append it. So for this function, we're simply going to clean the list, get rid of unnecessary values. So let's make if index squares so what we've got here is if the index modulo the squares, the amount of squares we have, is equal to 0, this will be true. And we can make a temporary number equal to the length of the checks we have in the list. So we can check and iterate over the lengths in the list. So if we have a number of 0, 10, 20, 30, etc., all of these modulo the squares will all come up 0. So we've got all of these here. Now to get all of these on the bottom side, we need to simply add 1 and then check the modulo of the squares, and then that will be true. So we can repeat this over here. But I'll finish writing this one first. So we've got every value we want, and now all we need to do, we'll use a while loop. So while num is greater than 0, we want num minus equal to 1. And we go if, put this in brackets, check, because I'm not sure if we need it yet, to be honest. Then we go plus 1, so the index value plus 1 mod the squares on the x is equal to 0. We simply delete that value. So for the values of 0, we need to delete all values that have a 9 in it. So if we add 1 to them, all the values that are indexing on the other side, and then get the mod, we're going to get the true statement. So all of these here we can simply delete using a delete. So we can now go delete, check, num, and we're deleting that value from the checklist. And now all we do basically the same thing, though as I said, we can simply copy and paste, and let's just let's get this right place, make this an elif, and this time we want index plus 1, because we're checking the squares on the other side which end in a 9 and checking if this mod is equal to 0. Then this time we get rid of this plus 1 here because we're getting rid of all the values on the other side of the map again, and we're deleting the index. And now we can append to the list such that we can go blocks using this index. Since we passed through the index, so using the current block we are dealing with, we'll simply append the leftover list after we have deleted the required values, and we'll call this check. Let's get rid of that. This makes it a bit neater. I think that's all we need, to be honest. Save that. Let's save run this. Oop. Yep, I forgot one thing. I forgot to reset the blocks inside of here. As we can see, they keep growing. I think I need to reset them just here. So I'm slightly going from memory here. Okay, now let's see if this worked. I'm going to close this so it's easy to view. F5. We've ran too many already. And now, as we can see, let's check a couple of values. I'm getting pretty excited. I'm sorry, guys. 0. 0 has 1, correct. 10 and 11, correct. Cool, it's got its right list. Let's check 1. 1 has 0, correct. 2, correct. It has 10, 11, 12, correct. Beautiful. Now let's check something we can find easily. 14 is something we've dealt with often. So it's 10, 11, 12, 13. 14, right here. 14 should have 3, 4, 5, correct. 13, skip 14, has 15, correct. 23, 24, 25, correct. So now we can use these values to check the objects next to it. And by getting values from the ones next to it, we can create a game of life or other board games. We are very close. Just follow the link and we're almost there. One thing I should quickly mention is that you might notice we did not return anything to this board game in here. We simply ran it. And inside of here, we are appending to the list. Since the list itself is passed by reference, we can append to the list. We're not passing it by value. You can check a link to my other video to talk about that in functions. But because we are passing it by reference, by appending to the list itself, this list is being changed. And we no longer have to pass anything back. I thought that was quite handy. And now that we have this module on the left here, we can make board games. And now using this module on the left here, we can make board games and draw really cool things. We can make it to make spiral patterns, etc., etc., changing some of the maths.